In this example, we'll be going over subtracting two rational expressions. So I'll be subtracting 7 over x squared minus 9 and 1 over 4x plus 12. So to start here, what I'd like to do is factor anything that can be factored in the numerators and denominators. So I see x squared minus 9. That's going to give me a difference of squares, which will be x minus 3 and x plus 3. So I'm going to factor that. And then in the second denominator, I can see 4x plus 12. So I'd like to factor 4 out and rewrite that as x plus 3. So I'd like to have all this over one denominator so I'm able to subtract them. So I'm going to need to come up with a common denominator for the first denominator here and the second one. If I look at the first denominator, I can see I have x minus 3, x plus 3, but I don't have a 4. So I'm going to multiply the top and bottom of this expression by 4. And if I look at my second expression, I have a 4 and x plus 3, but I don't have x minus 3. So I'm going to want to multiply the top and bottom of this expression by x minus 3. So doing that, I've got 4 times 7 is 28. And then I've got that denominator of 4 outside of x minus 3 and x plus 3. There's my second rational expression here. I've got 1 times x minus 3, which is x minus 3. And I get that common denominator of 4 outside of x minus 3 and x plus 3. So now I'd like to combine these, but in order to do that, I need to ensure that this negative sign, or subtraction sign, is distributed with both terms in the top of the second denominator. So when I do that, I'm going to have 28 minus x, and the minus here, along with the minus in front of the 3, is going to make that a positive 3, or plus 3. This is a common mistake that students make, is that this negative sign doesn't get distributed here, and we end up subtracting the 3 when we're actually supposed to add it. And then I've got my common denominator of x minus 3 and x plus 3. So at this stage, I'd like to look at the denominator and find my MPVs for this expression. So the two expressions that contain x are x minus 3 and x plus 3, so those are what I'll use. So I have x minus 3 is equal to 0, which bringing the 3 over will give me x equal to 3 as one MPV. I'm going to have x plus 3 equal to 0, which will give me a second MPV of x minus 3. So I'm going to go ahead and further simplify this now, which we'll just follow over here on the bottom. So I've got 28 plus 3, which will be 31, minus x, over 4 outside of x minus 3 and x plus 3. So one final look now to make sure I have everything factored. I'm not going to be able to remove anything from 31 and x, and the bottom was already factored because we left it factored through the problem. So all I have left to do here at the end is state my restrictions, which I obtained from my MPVs. So I see that x can't be a positive or a negative 3.